Hello friends, I welcome you all to this session on C++ programming, that is numerical methods using C++. The today's topic is divergence of a vector field. You know, if I am having a velocity field, let's say, which is ui plus vj plus wk. Now u, v, w are the components of velocity in x, y and z directions. Now, what is divergence? It is normally represented as nebula dotted with v vector. So, divergence represents that whether a flow field converges to a point or it is moving away. So, if the flow field lines are going like this, then this is sort of a divergence, means flow is diverging from this particular point. So, this can be thought of as a source. Whereas this you can think as a sink. Okay. So if divergence comes out to be positive, that means this dot product, then that is a positive divergence. Whereas if it is negative, then this is the one example of negative, that is the convergence. Now, how to write the code for it? Friends, already majority of the part you have already done. Now we just have to little bit tweak. So let's say the x component of velocity is xy, y component of velocity is x square plus y square, and the z is 3x y square. Or let us take z also into picture. Let's say this is the one. So these are the three components of velocities in the x, y and z. So the first part of the program must be to define these velocities. Okay, so what I have done here is I have bought that differentiation function because I'll be using this in the program. And now I will be defining three components, that means velocity components. So let's say x component of velocity, let us make it bigger, vx, or we can write u instead, doesn't matter. And here, let me copy this, and that's it. Okay, so now this will be what, x, y, z. So x into y into z, so it should be x. Now the y component of velocity, that is v, and this is x square plus y square. So let us make it x square plus y square. So as we are using this function, so we'll be using C math here. Now this is v, and then finally the z component of velocity, that is w, and here it is 3x y square z. So it is 3 into x into y square into z. Now we are having three different functions for velocity components u, v and w. Now when it comes to divergence, so what you have to do is you have to take the dot product, and you know that the nebula is I del by del x, j del by del y, k del by del z. And when this is dotted with this velocity vector, that is this one, so what you will be getting is the divergence of this velocity vector, that is del u by del x plus del v by del y plus del w by del z, and this is basically a scalar quantity. Okay, so what your program should do, first it should call that differentiation function onto this u, and then evaluate the derivative with respect to x, then again call it and pass this v velocity there, v velocity function, this is v basically, and this is w. So differentiate with respect to y, and then here again call that differentiation function, pass w, and do the differentiation with respect to z and add them. It is so simple. So what we'll be doing is, in the main, we have to define basically first x we can define as 1, y we can define as 1, and z we can define as 1. You can write like this also: x assign 1, y assign 1, z assign 1, the same thing we are writing here. Or you can also define the variables like this in C++. This is a very elegant way. This is what we call, I think, uniform declaration, I think. So if you want to see what is x, then it will say it is 1. Okay, this is one of the way. Now x, y, z, apart from this, you also should have h, and let us take this h as 0.001. Okay, now what we have to do is, we have to find out the divergence. So let us take one variable div. And what is this div? Div is basically a scalar quantity, that is differentiation of u, which is having x, y, and z as parameters, along with h, and this is done with respect to x. Okay, this is what? This is del u by del x. Then what? Then with respect to v, this is del v by del y. Sorry, with respect to y, we have to differentiate v. And then z, that is the w, z component of velocity, which is represented as w, we have to differentiate it with respect to z. Once this has been done, we can simply say C out divergence is equal to div. Run it. So it is coming out as 6. Let us check whether it should come 6 or not. So if you find the partial derivative of u with respect to x, then this will become yz. Here, if you find the partial derivative of v with respect to y, so this will become what? 2y. And if you find the partial derivative of w with respect to z, so it will become 3xy square. So if x is equal to y is equal to z, and that is equal to 1 for x, y, and z as 1, so this will become 1, this is 2, and this is 3. So 3 plus 2, 5 plus 1, 6. And what we were getting? We were getting 6. Simple. So friends, in this way, what you can do, you can evaluate the divergence of a vector field. And now, as you know how to evaluate the divergence, I am leaving this as a problem for you to find out the curl of a vector field. Before I leave, quickly I'll tell you how to evaluate the curl, that is the rotational tendency of that particular field. So it is I j k del by del x, del by del y, del by del z, u, v, w. We just find out the determinant. So it will be del w by del y minus del v by del z minus j. I am writing below. So it is del w by del x minus del u by del z, and for the z component of curl, it is del v by del x minus del u by del y. So what you can do is, you can find out the derivatives. Okay, even you can write your own function for the curl using those concept of derivative which I have already explained to you, and then you can evaluate these derivatives and write them in the correct order. That's it. Okay, so you take this as a assignment, as a challenge, as a practice problem, that is finding out the curl, and do it. The programs will remain more or less the same. You have to do tweaking. So in this lecture, till this point only, thank you very much for watching it. Take care.